class.
Okay. Okay. We will waiting your friend in 2 minutes. Okay, only 2 minutes. The class will start at 10:35. Okay, it's there are only 10 students. It's a 10. Okay, we will be waiting another 2 minutes. Oh, hello. Can you hear me? Can we start now?
Yes,ครับ
Yes, อาจารย์
Okay. Can you see my slide?
Yes.
Okay. If you don't see or if you don't listen my voice, okay, you can tell me, okay? Because due to the online exam, I may be click some things wrongly. Okay. We can continue from the next chapter. The chapter 7. In the previous chapter, I teach you the first transform of engineering, okay? Field is a Fourier transform. Okay, the Fourier transforms, you can convert the signal in time domain into the frequency domain. Okay, everything in the Fourier domain is very beautiful and very powerful. Okay, but it have a limit of using. Okay, the Fourier transform, even though okay, you can determine the Fourier transform and you can determine the inverse Fourier transform from the function in time or the function in the frequency domain directly, but the limit, the main constraint of the Fourier is the signal in time or the signal in the frequency domain, ft and f omega, must be stable. Okay. How to check them stable is mean, okay, you can use the Dirichlet condition to check them. Okay. The term stable is seems okay very makes sense that okay if the signal is unstable, it's impossible to determine the the Fourier transform pair. Yes, but the limit of the using is came from that point. Okay, if the system that you would like to analyze is unstable, it means you cannot apply the Fourier transform to them, because when you apply the Fourier transform to them to determine the system function, it means it's infinity. It's useless. You cannot use the Fourier transform to the unstable system or unstable signal, because the result is infinity. You cannot do anything. That's why we will develop another transform. We call them the Laplacian form. The Laplacian form, you can apply them to the broader signal than the Fourier. It means you can see them to be a stable signal and an unstable signal. Okay, but the Laplace transform is that make the Laplace transform is very powerful tool to analyze the system point of view. Okay, the application of the Laplace transform, you can apply them to analyze the system, such as the feedback control subjects, okay, or the power delivery system, power transmission system. When you see the system as a very big one and maybe stable or unstable that you're not sure, okay, you will apply the Laplace transform first. But it have a limit of the using. It means you can determine the Laplace transform, but you cannot determine the inverse Laplace. Okay, you cannot directly, because the formulations to determine the inverse Laplace transform is extreme difficult. Okay, therefore, when we would like to determine the inverse Laplace transform, we can apply them only on a special case of the Laplace transform. It means the form must be in the polynomial and you can factorize them and you can use the table to invert them back into the type. Only that special case of the Laplace transform that you can determine them. Now, we go to the overall point of view concept completely. Now we go to the main concept of the Laplace transform. Okay. The chapter 7 discuss about the Laplace transform. Okay. The overall idea is the continuous time, the Fourier transform or the CT-FT can be used to represent the signal as a linear combination of the complex exponential form E j omega t. Okay. But this chapter develop a generalized of the continuous time Fourier transform known as the Laplace transform. You can see that the Fourier transform, you can convert, okay, the signal into the complex exponential, the imaginary exponential form here. But the Laplace is more broader, okay. It's not only comprised by the imaginary, no, it will be comprised by the complex instead, okay, the complex instead. S in this case is comprised by the complex number, okay. Consequently, the Laplace transform can be applied to the stability analysis of the system and play a crucial role in the investigation of the stability or instability of the system too. Yeah, the idea of the Laplace transform, we will separate them in about the X topic following that. The first one gives you the definition of the Laplace transform first. Later, provide you the idea of the region of the convergence of the Laplace transform. And after you know about the ROC or the region of the convergence, you know how to find the inverse of them. Later, how to plot the Laplace transform. Even though you cannot plot them directly, but you can estimate them, okay, to be the Fourier transform and plot them in the frequency domain. This thing is called the relationship between the pole and the polar plane, okay, and about the magnitudes and the phase plotting will be shown you in the geometric evaluation of the continuous time Fourier transform, but we apply on the Laplace transform in this case. Later, we discuss about the property of the Laplace transform. The next one is about the some common Laplace transform pair on the table that I will provide to you. Okay. The 7th and the 8th topic is about the application of the Laplace transform. Okay, discuss about the analysis of the characterization of the LTI system using the Laplace transform and the system function algebra and the block diagram representation. Okay, the first one is the definition of the Laplace transform. Okay, the bilateral Laplace transform of the general continuous time signal will be defined by here. Lxt equal to integrate from minus infinity to infinity xt. E, instead we use minus j omega t, no, we use minus st. But s is a complex number, not imaginary like the Fourier. Okay, s is a complex variable. Okay, show you in the equation 1. But the second one is more complicated. The inverse Laplace transform, okay, is defined by here. You can see that the inverse Laplace transform require the control integration. Okay, you integrate from the one complex form, okay, follow that part, okay, to another complex variable xs. That's why, okay, from your skill now, no subject teach you how to determine the contour integration. Therefore, the way to determine the second equation directly is impossible. Okay. Therefore, we in the engineering application, we never determine the inverse Laplace transform from the definition directly, but we determine them from the partial fraction technique instead. Yeah. The bilateral Laplace transform is integrated starting from minus infinity to infinity, but the unilateral is the special case of the Laplace transform. Is defined to integrate only one from 0 to infinity instead. We call them the uni. Uni is mean only one. Uni is one. It means only one side of the plane. Okay. Bilateral is mean you integrate both sides of the plane from minus starting from minus infinity to infinity. Okay. Therefore, the unilaterals of the Laplace transform of the general continuous time signal xt will be defined by the equation 3. Integrate from 0 to infinity. Yeah. The Laplace transform Lt of xt is usually denoted as Lxt, and the relationships between xt and its Laplace transform xs will be indicated at the equation 4. Xt, xs. Okay. Xt is a function in time domain. Xs is a function in the Laplace transform domain. Xs. Okay. The relationship is derived by the Laplace transform and the inverse Laplace transform. Both the Laplace transform and the continuous time, the Fourier transform, have a number of important relationships. Therefore, this section explores these relationships. The first one is the complex variable s can be expressed as the complex form is here. Okay, the Laplace transform, you can see them to be the superset of the Fourier. Okay, the Fourier s, okay, if you express the Fourier in terms of the Laplace transform, it's the same, except the real part of the Fourier s in Fourier is a 0. Therefore, the Fourier will be comprised by only the imaginary term. Okay? But the Laplace is not. The Laplace is a complex term, where the gamma is the real part of S and omega is the imaginary part of S. Okay, you can substitute S gamma plus J omega in here and S by gamma plus J omega in here. Okay. Okay, in this term, okay, this term E A plus B equal to E power A and E power B is here. Distribute them in this, okay, and this term you can push them in the bracket in here. Okay, the term X gamma plus J omega is the continuous time Fourier transform of the signal xt multiplied by the real exponential E minus gamma t. Therefore, okay, this term, you can see them to be the Fourier transform of xt, but you multiply by the E power minus gamma t, okay, as shown you in the equation 7, okay. This term, you can see that this term is a decaying term, right? E minus gamma t, okay. The exponential term, E minus gamma t, may be growing or decaying with the increasing t that depend on the gamma. If the gamma is positive, this term is, okay, decreasing and close to 0. But this term is negative, this term will be increasing and bound. Okay. In the special case, if the gamma is a 0, okay, the Laplace transform is reduced to be the Fourier transform too. Okay. In this case. Okay. And the Laplace transform reduced to the Fourier transform when the real part of the transform variable S is the 0. Or it's not purely imaginary. Okay, S, okay, equal to gamma plus J omega. If gamma equal to 0, equal to J omega only, this term is become the Fourier transform. And the range of S is very important. The range of S refers to the region of the convergence. If the ROC includes the imaginary axis, then the Fourier transform is also exists too. Okay. Therefore, for the Laplace transform, when you plot them, okay, you must know what about the range of S, okay? If the range of S is here, plot in the S plane, complex plane, okay, it have the real part, it have the imaginary part, okay, you can see that. In this case, if the polar case in here is mean the ROC will be not include the imaginary. If the ROC of the Laplace transform does not contain the imaginary, it means that Laplace transform have no Fourier. It will be have the Fourier only in the case that, okay, the ROC will be include the imaginary axis or include this line. Okay. Okay. In order to give you more understand about the Laplace transform, okay, I will provide you many examples. okay, first, okay, yeah. The first one, okay, determine the bilateral Laplacian form of the functions ut and get the ROC, okay. Ut is mean, okay, the unit step function. For time less than 0, it equal to 0. For time greater than 0, it equal to 1, okay. The bilateral is mean you integrate from minus infinity to infinity, okay. From the definition, the bilateral Laplacian form of a continuous time function is given by the equation 1. Okay, given by the equation 1. Okay, here. Okay, and you integrate from minus infinity to infinity. Substitute xt to be ut. Okay, and in this case, you can see that the range of the integration, okay, can reduce to be 0 to infinity because for time less than 0, it equal to 0, right? If it equals to 0, nothing for integration. Okay, therefore, the range of the integration you can change to be 0 to infinity. 0 to infinity. Xt during that period equal to 1. Okay, 1 multiply anything give you that thing. Okay, now you integrate EAT. Integrate EAT give you EAT divided by A. Divided by A. A in this case equal to minus S. Okay, and you substitute the range of them. Okay, from starting from 3 equal to 0. T equal to 0 to T equal to plus infinity. Plus infinity. Okay, this term, anything power minus infinity equal to 0, and anything power 0 give you 1. Therefore, the Laplacian form of the unit step ut in this case equal to 1 divided by s. 1 divided by s. Okay, and what about the ROC of them? Okay, how to determine the ROC? Okay, therefore, the Laplacian form of this function exists only. Okay, you plot them first. Okay. In order to determine the ROC or the range of the convergence, the region of the convergence of this function, okay, xs will be equal to 1 divided by s, okay. You plot, you get the pole location first. What about the pole location? You set the denominator equal to 0 first, okay. In this case, we have only one pole because we have only s pole 1, okay. And the pole, you set denominator equal to 0, s equal to 0, okay. S equal to 0, it means you have only one pole, and the S equal to 0 is mean the pole located at the 0 location is here 0. Okay, and okay, in this case, the function will be in the right-hand side function. The right-hand side function is mean the function that is non-zero for the right-hand graph. Okay, right-hand side of the axis. Okay, in this case, therefore the ROC will be the right-hand side too. Okay, but the ROC cannot contain the pole location. Okay, therefore, in the boundary, okay, for the real part equal to 0, okay, it will be dashed line. It means the ROC never includes 0 in here. Yeah. Now the ROC will be greater than 0 for this case. Okay, the real part of the ROC will be greater than 0. Okay, the second one. Okay, the second example is here. Determine the bilateral Laplacian form of the function xt when, okay, xt equal to e minus at ut. Okay, if a is greater than 0. Okay, if a is greater than 0, you can see that, for example, if a equal to 5, if a equal to 10, you can see that it will be decaying exponential. Okay, for time less than 0, the ut, right, unit step equal to 0. Time greater than 0, it equal to here. Okay. Now, after you must get them first, okay? If you don't get them, you never know what about the range of the xc is. And when you integrate them for the bilateral Laplacian form, you integrate from minus infinity to infinity. In this case, the range of the integration is reduced to be 0 to infinity. From the definition, the Laplace transform, okay, the bilateral Laplace transform of a continuous time function is given by equation 1. Okay, given by equation 1, and you substitute xt equal to e minus at ut. Okay, ut, and this graph is here. It means the range of the integration you can reduce to be 0 to infinity instead from minus infinity to infinity. Okay, 0 to infinity. Okay, now you can group them, okay, to be EAT. Okay, EAT. You integrate EAT, give you EAT divided by A. In this case, A equal to minus, okay, S plus A. Okay, S plus A. And you substitute the range of them from 0 to infinity. Okay, 0 to infinity. For infinity, Multiply anything, give you infinities, okay? Something power minus infinity, give you 0, okay? Anything's power 0, give you 1. Therefore, you can conclude, okay? You can summarize them and you can simplify the Laplace transform xs to be 1 divided by s plus a, okay? For this case, checking first, you plot them, okay? The pole, we have only one pole because we have only one s, okay? The pole locate at, okay, you set the numerator equal to 0. S plus a equal to 0, s equal to minus a, okay? S equal to minus a, okay? It's here. And the ROC is not include the pole location. Therefore, it will be dashed line. Okay. And in this case, you can see that the ROC is also includes the vertical axis, right? The imaginary axis. Therefore, this function is not only have the Laplace transform, but also it have the Fourier transform too. Okay. Now the next one. Okay. Okay, this function xt equal to e minus at ut. This function have this graph sketching. Okay, you must sketch them first. Okay, unless you never know what about this. Okay, minus at ut is here. I think some of you don't know. Hey, where the graph is came from, right? Wait a minute. Hello, can you see my whiteboard?
Yes.
Yes, student.
Okay, minus e minus at. Okay, minus e minus at, right? Okay, I use the mouse, okay, to drawing them. Therefore, it's maybe not good, but I think at least it will make you a little bit more understand. Okay. Okay, you can see that this term is separate them in two, right? The first term and the second term. Okay. The second term is very easy, right? U minus at, the graph is here, right? UT, you know about them, right? U minus at. What about U minus at? Time or amplitude reversal? Is a time reversal, right? Therefore, it's here. Sorry. 0 u minus at. Okay, for the first term, this term, okay, for this term, okay, you can see that for this term, okay, you can see that, okay, you must take two steps, right? EAT, okay, and you take amplitude reversal, or amplitude reversal minus here for the amplitude reversal, minus this is, okay, to be minus t, okay, it will be time reversal, okay. Okay, therefore this graph will become here, okay, the first step, okay, e minus at, okay, e minus at is decaying exponential, right? Okay, and you have minus in here, it will become flip in the vertical axis, right? Right. Therefore, this graph will be here. Okay, you get the blue graph. The blue graph is about here, right? Okay, you multiply between the blue graph and the red graph, right? Blue graph and the red graph. What happened? For time greater than 0, you can see that time greater than 0, the red equal to 0, right? The response, the all response equal to 0, 2. Okay. For time less than 0, okay, the red equal to 1. 1 multiply anything, give you that thing, right? Give you that thing, okay, give you here. Okay, that's why this is the result that I show you in the graph. I think even though it's okay, the graph I write is not beautiful handwriting, okay, but at least we give you more understand, okay, where it came from. Clear? Now we came back in here. Can you see my slide?
Yes,ครับ
Yes.
Okay. Okay. Now you know that, okay, where it came from. E minus, okay, minus E minus AT, U minus C. Why the club is in this shape already, okay? Now you can see that if you don't sketch them, you never know the rank of the integration, right? Now when you sketch them, you see, yeah, you can see that, okay? Instead, you integrate from minus infinity to infinity. No, the rank of them, you integrate from minus infinity to be 0. And for time greater than 0 to infinity is equal to 0. Okay? Now you integrate from minus infinity to 0 and this term. Okay? Integrate them is the same. Integrate EAT. EAT give you EAT divided by A. Divided by A. But A in this case is minus S plus A. Okay? Minus S plus A. Substitute the rank. The rank of them in this case is different from the previous example. The rank is starting from minus infinity to 0. Minus infinity to 0. Okay? 0 multiply anything give you 0. Anything power 0 give you 1. Okay? Anything power minus infinity give you 0. Okay? You get here. Now, when you reach this point, clear? When you reach to this point, if you can recognize in the previous, you can see that the Laplace transform of this is S plus A, right? S plus A. How many pole we have? We have, if you have S power 1, you have only 1 pole. And the pole locate at, okay, when you set S plus A equal to 0. S plus A equal to 0. Therefore, S equal to minus A. Hello? Anyone can hear me? My internet will be interrupted a little bit.
Yes, ครับ
Yes.
Okay. Okay, we can continue from the previous, okay? Is here, okay. Okay. We reach to this point, okay? The pole locate at minus A. But, this, in this case, the function is a left-hand side function. Due to xt is the left-hand side, you can see that if x, okay, xt is mean, it's okay for the left-hand side is non-zero, okay? When xt is non-zero, right? Not equal to 0 for the left-hand side, the ROC will be in the left-hand side too. Now, when we stop for a while, okay, you can see that in this case, the Laplace transform of the function equal to 1 divided by S plus A, right? 1 divided by S plus A. In the previous example, okay, the Laplace transform is S plus A. It's the same, S plus A. But the function xt is different, right? One is the left-hand side, one is the right-hand side function, okay? Now you can see that, but the ROC of them is different, okay? This if the Laplace transform is S plus A, but the ROC will be right-hand side. Xc from the inverse Laplace transform that came from this function must be decaying exponential in the right hand. But if it's the left-hand side, it will be in this function instead. That's why when you must determine the inverse Laplace transform, you must use the ROC combined with the XS. Only XS is not uniquely to determine XT. Okay, that's why when you observe in the example 1.2 and 1.3, you can see that the Laplace transform is the same, 1 divided by S plus A. But in 1.2, it's the right-hand side sequence, okay, and the ROC will be right-hand side. But for this 1.3, in this example, okay, the function will be the left-hand side and the ROC will be left-hand side too. Okay. Now, what about the detail of the ROC? Okay. Now for the Laplace transform that you get, okay, we usually get the rational Laplace transform xs will be in the polynomial of the numerator and denominator term, where ns is the numerator polynomial and ds in the denominator. You know that if you set denominator equal to 0, you can plot its pole location. But if you set numerator to be 0, you can determine and plot the 0 location. The pole and the 0 location that you plot in this step is very important in the system analysis, in the feedback control and the other subjects. Okay. In the rational Laplace transform, the numerator and denominator polynomial can be specified by this rule. Making the location of the root of the numerators and denominator in the S-plane. The location of each root of the denominator polynomial indicates with x, and the root of the denominator polynomial r refers to be the pole location. Okay. For another one, okay, the location of each root of the numerator polynomial indicate of the circle or O dot. Okay. The root of the numerator polynomial are refers to as the 0 of the x-set. Indicating the ROC provide a classical method of describing the Laplace transform. From the example 1.2 and 1.3 that you already studied, the function x minus at ut and the function xt minus eat and u minus t have the same algebraic expression of the Laplace transform. It provides you 1 divided by s plus a. But the ROC, or the region of the convergence, or the set of the value of s for which the expression is varied is different in two examples. The traditional method of to get the ROC is as following here. The variable s is a complex number, therefore the complex plane is usually referred to as the S-plane. Okay. In this axis, the x-axis will be the real and the y will be imaginary. Okay. The horizontal axis is the real and the vertical axis is the imaginary. Okay. Real and imaginary. Okay. Okay. The shading region represents the set of the point in the S-plane that correspond to the ROC. Okay, we plot the 0 by here. You determine, you set numerator equal to 0, factorize them, okay, and you determine, okay, each root of that, okay, you get the 0 location. The pole we use X mark, okay, the pole we use here, okay. And remember that the ROC, when you sketch that, it cannot contain the pole. The pole must be outside the ROC. It may be contain the 0, we don't care. But the pole is not. The pole is mean, in the physical meaning, the pole is mean the value that of S that make the system or the signal unstable or infinity. Yeah. If the Laplace transform X such as s minus 1 divided by s squared plus 3s plus 2 have an order of the denominator exceeds the order of numerator by k, then X have the k0 at the infinity. Yeah. For example here, if the Laplace transform of X is here, s minus 1, you can see that in this term, the 0 we have order 1, right? And the pole we have, the denominator is order 2, therefore we have 1, 0, we have 2 pole, okay, in this case, okay. Therefore, it have the denominator order 2 and numerator order 1. Therefore, in the mathematics point of view, okay, the numerator and denominator in the theoretical will be have the power equally, okay. In this case, the power of numerator is 1, therefore another 1 will be at infinity, okay. Because, okay, the power of the numerator, the maximum power in this case, the power of the numerator is 2, the power numerator or the 0 is 1. It means you have 2 pole, you must have 2 0. But in this case, you have only 1 0 for this, okay? Therefore, another 1 is located at the infinity. Okay, the detail for analyze the advanced topic will be discussed maybe in the 4th year subject or maybe in the master subjects, okay? Now, another point of view. If you have X as this form, okay, you can see that this term, okay, power of numerator is 2. The maximum power of numerator is 2. And the power of the numerator, we have factor 1 and factor 2 in here. Therefore, factor 1 and factor 2, okay, therefore, you have 3 pole. You have 3 pole. The numerator power 3, you have 3 pole, okay. And the 0, numerator you have power 2, order 2, okay? You have 2 pole, 2 0, sorry. You have 2 0, you have 3 pole. Therefore, in the theoretical, number of pole and the number of 0 must equal, okay? Therefore, in the theoretical, it means another 0 must be located at infinity, okay? If the Laplace transform xs is here, such as s minus 1 divided by s squared plus 3s plus 2, have the order of numerator exceeds than the number of denominator k, then xs have the k pole at the infinity instead. Okay, the complete specification of the Laplace transform is the algebraic form of xs and its ROC. If the ROC of the Laplace transform includes the imaginaries or j omega exists, then that function have the Fourier transform too. Yeah. Now, in order to give you more understand, okay, we will provide another group of the example. Determine the bilateral Laplace transform of the function here. Okay, in this case, if you have two functions, you can see that. Okay, two subfunctions, two sub-mathematical functions. You can determine the Laplace transform of each subfunction first. Okay, and for the ROC, the overall ROC equal to the intersection of each of them. From the definition, the Laplace transform, the bilateral Laplace transform of the continuous time function will be given by the equation 1. You substitute sec t in here, give you here, okay, 3e minus 2t ut minus 2e minus t ut. You can distribute, okay, e minus st into each term, and you separate the integration into each term too. Okay, when you separate them, okay, each term have its own ROC. You can see that the first term is here, es plus 2. The second term, es plus 1. Okay, you can integrate them. Okay, substitute the range from 0 to infinity. 0 to infinity. Okay, anything power minus infinity give you 0. Okay, anything power 0 give you 1. Okay, the same. You group them. Okay, you can see that you separate them in two terms. Therefore, each term have its ROC. The first term is have the pole located at minus 2, and the ROC will be greater than minus 2. Okay. The second term, you check in the denominator term. Okay, denominator to be 0. Therefore, the pole located at minus 1. The ROC will be greater than minus 1. Now, I will show you sketch them in the graphical point of view. What about the pole location first? Okay. Yeah, you grouping them. Okay, after you grouping them, it will provide you clearly what about the pole. The pole, you have two pole location. The first pole located at minus 2 and the second pole located at minus 1. Okay, you have only 1 0 in here, right? 1 0 in here is mean, okay, in fact, in the theoretical that you already studied, you know that if you have two poles, you must have 2 0. But in this case, the function provide you clearly 1 0. Another 1 0 located at infinity that we don't discuss them. Okay. Now for the pole located at minus 2 is here. The ROC will be greater than. Okay. And the second pole located at here at s minus 1. Okay. The blue one, and the ROC will be the blue one. Okay. What about the total ROC in this case? The total ROC is the intersection of the yellow and the blue one. Okay. Therefore, the overall ROC will be, okay, right, the blue one is here. The overall ROC will be greater than minus 1. Okay, and in the right hand side is here. Okay, now another one example, okay, that maybe provide you more understand about the Laplace transform. Okay, determine the bilateral Laplace transform of this function. Okay, this term it have two subfunction again. Okay, from the definition, the bilateral Laplace transform of the continuous time function okay, will be given by here. Okay, distribute them in each term. Okay, multiply them. Okay, distribute the e minus st to each term and distribute them in here. In this case, e minus t cos t. The cos is, okay, it's not a simple function. Therefore, you can express them by use the Euler relation. Okay, cos theta equal to e minus j theta divided by 2. Okay, plus e plus j theta by 2. Yeah, distribute them in here. Now you distribute them into 3 terms, okay, and you integrate them. Okay, integrate EAT. Even though this thing you have 3J, 3J is only the constant. Okay, because in this case, when you integrate them, you integrate respect to time, respect to t. For the other parameter, you see them as constant. Okay, now, okay, you have three terms. Integrate EAT, give you EAT divided by A. The first term, A equal to minus S plus 2, okay? The second term, A equal to minus S plus 1 minus 3J, okay? The last term equal to, okay, minus, okay, S plus 1 plus 3J. Okay, after that, you substitute the rank of them, okay, from 0 to infinity. We can simplify that, okay? And you get here. In this case, you can see that we have, in this case, we have three pole location, okay? The first pole located at minus 2. The second pole is located at minus 1 plus 3J. And the last one is, okay, the pole located at minus 1 minus 3J, okay? Okay, now in this case, the Laplace transform of them keep you here, okay? Or you can grouping them, you distribute them, multiply them, keep you here. You can see that therefore the Laplace transform of this function will exist, okay? For, okay, you plot the pole first, okay? The first pole located as minus 2. Oh, sorry, we have 2, 0 in this case, okay? The 0 is, the 0 you can see them clearly after you merge each term together, okay? After you get this polynomial, 2s squared plus 5s plus 12, okay? And you can determine the 0 location when you set the numerator equal to 0. And from the quadratic equation, ax squared plus bx plus c, x equal to minus b plus minus square root b squared divided minus 4ac divided by 2a. Okay, you can get two locations in here. And this, okay, the pole, the first pole located at minus 2, and the second pole and the third pole located as, okay, you can see that minus 1 plus 3 minus 1 minus 3, okay? Okay, the first pole located here, the ROC will be the zero, okay, the zero club, okay, the zero region, okay? And the second one, okay, and the third one is the same. The ROC will be the blue one. Therefore, the overall ROC will be the intersections from that case, okay? It will become, yeah, okay? It will become the green zone, and it means the overall ROC is greater than minus 1, greater than minus 1. Okay, next one, okay, next one determines the bilateral Laplace transform of this function, TUT, okay, TUT. From the definition of the bilateral Laplace transform of the continuous time function, you integrate from minus infinity to infinity again. But in this case, okay, you have ut, right? You have ut, okay, for time less than 0, it equal to 0. Time greater than 0, it equal to 1. Therefore, the Laplace transform equation can reduce the integration to be, okay, to be 0 to infinity. 0 to infinity. EAT, you can see that EAT, when you integrate them, it requires your bypass skill, okay? Require your bypass skill, okay? From the Bipart integration, integrate u dv equal to uv minus v du, okay? And in this case, we set u to be t and v to be e minus st, okay? After you distribute them or you remember the closed form equation, okay, you get here, okay? Substitute the rank of them, okay? And you get only this term. You can see that in this case, you have s squared here. It means how many poles you have? You have only 2 poles. But both of them will be have the same location. The pole located at 0. Okay? The pole located at 0. Okay? The Laplace transform equal to 1 divided by s squared. Okay? You can write them in here. The Laplace transform of the function will be exist in here. The first pole located at the 0. The second pole is the, okay, the first pole is the red one. The second pole is the green one, but located at the same location. And the ROC in this case. Therefore, the Laplace transform of this function exists for the real part greater than 0, and the s will be in the right half of the s plane. And in this case, you can see that, okay, the ROC will not include the imaginary function, imaginary axis. Therefore, this function have only Laplace transform. If you try to determine the Fourier transform, it's infinity. Okay, it means it have no Fourier transform in this case. Now for the last one, okay, the last example, okay, 1.7, okay, determine the bilateral Laplacian form of the function psi, bt, ut, and sketch the ROC of them, okay. Psi, bt, ut, okay, in order to determine this, okay, ut, you can see that ut, you can reduce the range of the integration starting from 0 to infinity, okay, and after that, you can use the Euler expression, psi bt equal to e minus jbt plus, e power jbt minus e minus jbt divided by 2j, okay. Distribute them, okay. This term, you can see that you grouping them something power t, okay, something power t. You move them in the bracket in here, you get here. EAT, you integrate EAT, give you EAT divided by A. But A in this case is not real, okay? It can be complex. A equal to minus S plus JB and minus S plus JB. Okay, you integrate them, substitute them. After that, you can reorganize the form is here. Okay, you can see that this Laplacian form of the size ut is equal to b divided by a squared plus b squared. In this case, how many poles we have? We have 2 poles. The first pole located at minus bj, okay, and the second pole is plus bj, okay. In the ROC sketching point of view, we will show you in here. Therefore, the Laplacian form of this function will be exist only for the real part of s will be greater than 0 because the pole located at here minus b and plus b in here. Okay, you can see that even though the intersection will be the same and identical, the overall ROC will be the zero part. Okay, the zero zone is here. Okay, the next one. The next one is, okay, determine the bilateral Laplacian form of the signal xt that show you in this case. You can see that this graph is not simple like the previous, okay, but it's not too difficult. This part, this graph is already show you in the piecewise straight line that I already teach you, okay, you cannot push this graph into the Laplacian form equation directly. You must write them in the mathematics form first, okay. Do you remember the chapter 2 that I teach you, okay, how to write xt in the form of the mathematics form, okay. Due to xt is in the graph form, okay, the signal xt must be is written sorry for that, a little bit one. Okay, okay. Therefore, due to xt is in the graphical form, okay, the signal xt must be written in the mathematics form first, okay. The first one is, okay, the graph will be change the slope, okay. Therefore, one term is required, okay. The graph is change the slope again and change the value. Second term is required and the third term is required, okay. Change the value only suddenly. The last term is required, okay. The way to determine xt, to express xt, I already teach you in the chapter 2. After you get xt, you substitute them in the bilateral Laplacian form. Integrate them each term step by step, okay. This, you can see that integrate t, okay. You get, okay, in the form of 1 divided by a square, but it's shifting by 1, okay. You integrate them and set the range of them, okay. Okay, in this form separately, okay. Integrate from, okay, 0 to 1 minus infinity to 1 1 2 2 2 2 3 3 to infinity, okay. You get this form, okay. The key of this example is you can express xt in this mathematical form or not, okay. If you cannot determine the Laplacian form too, okay. Okay, it's your turn, okay. You can find, okay, you can wait a minute. Okay. Practice, okay, take the exercise. Practice, okay, 6.1. Okay, can you see in the meeting chat? Practice 6.1 to 6.3, okay? Do 6.1 first, okay? And I will provide you solution in 20 minutes. Any question?
No, sir.
Okay. Okay. Hello, can you hear me?
Yes, Ajahn.
Okay. It's time to turn on the camera. Okay, I will checking your attendance. Okay.สุพนัทมาก่อนเลยไง
ครับ
วันนี้
อาจารย์
โอ้โหใส่เสื้อตามสบายไม่ออกไปเที่ยวไหนเหรอ
ไม่ออกอาจารย์
อะไรกันเห็นรุ่นพี่เอง เพื่อนเองเด็กเอแบกเรียนออนไลน์ยังไปติดโควิดอยู่เลยไม่ใช่เหรอ
ใช่อาจารย์
มีเด็กเอแบกติดอยู่แต่ไม่รู้ไงบ้าง เห็นบอกไปกินข้าวกับเพื่อนมั้ง
โอ้
ไม่รู้ว่าไปกินข้าวหรือไปกินน้ำผลไม้นะ แบบในข่าว เราก็ไม่รู้
วันนี้
เซฟตัวเองนะผมไม่เดือดร้อนหรอกนะคือว่าไงผมสอบพวกคุณก็คุณเชื้อโรคมันไม่ติดทาง Wi-Fi อยู่แล้วไม่เป็นไรหรอก แต่ประเด็นมันอยู่ที่ถ้าพวกคุณติดนะนอนปังงาบเนี่ยเกิดอาการกำเริบปังงาบมันไม่ได้สอบเนี่ย มันจะตกซ้ำชั้นนะไม่ซ้ำมหาลัยไม่มีซ้ำชั้นหรอกเพียงแต่มันจะนะมันจะดีเลย์ไปใช่ไหม อยู่ดีๆเตรียมตัวสอบมาเสร็จแล้วเทอมนี้ขาดสอบหมดทุกวิชานี่เจ๊งเลย ก็เท่าที่ดูก็ดูท่าจะตั้งใจเรียนกันระดับหนึ่งนะคงไม่มีใครอยากสอบตกใช่ไหมแต่ชินอารมณ์เป็นไงบ้าง
ชิวๆครับอาจารย์
ชิวๆนี่คือนะแม้โดต้ามีให้ดูแล้วทำไมเริ่มแข่ง DBC แล้วถึงเวลาจริงมึงจะแข่งกันยังไงวะยังปิดประเทศกันอยู่เลย
แข่งออนไลน์ไหมครับแบบต่างคนอยู่ที่บ้าน
ไม่แข่งเมเจอร์มันแข่งออนไลน์ไม่ได้นี่มัน global ทั้งโลกอ่ะแข่งโซนตรงนี้มันแข่งในโซนใช่ไหมมันก็คงแข่งที่บ้านได้อะแต่เดี๋ยวพอเข้าเมเจอร์มันต้องคัดเลือกจากในแต่ละทีมมาในแต่ละประเทศมาน่าจะวุ่นอยู่ไม่งั้นเกิดเอาเซิร์ฟเวอร์ของยุโรปอย่างเงี้ยโอ้โหเล่นจากเล่นจากออสเตรเลียมาเนี่ยดีเลย์2 วิตายอย่างเดียวอะขนาดนิ้วขั้นเทพอย่างซูเมลแม่งยังเจ๊งเลยนะชนนิชาพอไหวไหม
น่าจะ
พอทำได้ไหม
กำลังลองทำ
นัชชยาล่ะเป็นไงบ้างตั้งใจทำอยู่ พัทรนันท์เป็นไงบ้างตั้งใจทำกันนะโอ้จอยกันพอสมควรโอเคwhat about you what DBO can you do this
ใช่นะ
ปิยธิดาล่ะเป็นไงบ้าง
โอเคค่ะ อาจารย์พอได้อยู่ค่ะ
ตั้งใจทำนะ
ค่ะ
แล้วธีรพัฒน์ล่ะเป็นไงบ้าง
พอได้ครับ
ง่ายไปไหม
ก็
ข้อสอบจะเอาแบบยากๆกว่านี้สัก10 เท่าไหม
เอาง่ายๆดีแล้วครับ
อะไรกันใจไม่สู้เลยรู้ไหมมีคนถามผมนะว่าลูกศิษย์ A-back ผมนี่เหมือนใครตอนนี้ผมบอกได้แล้วเหมือนใครพวกคุณเนี่ยนะเคยดูเรื่อง Demon Slayer ไหมดาบพิฆาตอสูรเนี่ยลูกศิษย์ผมเนี่ยเด็ก A-back 90% 80% เนี่ยแม่งเหมือนเซนอิสึประเภทไม่สู้ไม่เอาเจอข้อสอบเกาะต้นไม้หนีไม่เอาไม่สู้ยกเว้นว่าแบบนะเจอข้อสอบแล้วหลังชนฝานะก็แบบเลี่ยงไม่ได้แล้วถึงสู้อะไรอย่างเงี้ยแบบนะผมเห็นสภาพแล้วแบบผมต้องเป็นตาแก่ที่คอยมานั่งมานั่งฝึกพวกคุณไปสู้ต้องสู้นะต้องลากลงมาจากต้นไม้นะต้องคอยขุดหลุมดักไว้ไม่ให้หนีกลับบ้านต้องขยันไล่ให้ทำโจทย์นะตั้งใจทำงานถามว่าพวกเราก็มีความสามารถกันนะไม่ได้ไม่มีเลยถ้าไม่มีเลยมันคงสอบตกตายไปตั้งแต่แคลวันแล้วมันคงได้มาพบไม่โผล่มาหาผมถึงซิกแนลถึงเซอร์กิตหรอกนะเพียงแต่ว่าหนึ่งก็คือเราเนี่ยไม่อยากสู้ไงไม่อยากเหนื่อยไม่อยากเก็บตัวบวกขี้เกียจด้วยนะต้องขยันกันหน่อยสินะเพราะจริงๆถ้าถามผมนะเด็กนักศึกษามอลัสเนี่ยถ้ามอลัสที่ขยันเก่งๆเนี่ยมันจะเหมือนกับทันจิโร่มากกว่าคือถามว่าแต่มันก็ไม่ได้เก่งกว่าคุณมากมายคือความสามารถก็พอกันแหละแต่เขาขยันเขาสู้ไงไม่ต้องบอกให้เขาสู้เขาก็สู้แต่ครูว่าคุณนี่ส่วนใหญ่นี่เป็นเซนดิสึกันหมดแบบนะไม่เอากลับบ้านดีกว่านอนเกาะต้นไม้ขอนอนสบายๆไม่อยากเหนื่อยจะไปไล่ฟันปีศาจไล่ฟันข้อสอบทำไมนะ ตั้งใจทำกันแล้วเดี๋ยวอีก10 นาที มีอะไรไม่เข้าใจก็ถามได้ ผมนั่งอยู่ตรงนี้แหละนะ แต่ว่าแบบที่เห็นนะวิชาวิศวะมันไม่เหมือนวิชาอื่น ถึงผมจะให้ตัวอย่างคุณดู7 ตัวอย่าง10 ตัวอย่างแต่ถ้าคุณไม่ได้เขียนเองมันไม่มีประโยชน์หรอกนะ มันทำไม่ได้ แล้วเดี๋ยวถ้าหลังโควิดมันต้องมาสอนตัวเป็นๆเนี่ยเจอข้อสอบตัวเป็นๆนะ ในวิชาที่ต้องใช้วิชาเหล่านี้ด้วยนะแล้วคุณไม่ตั้งใจแล้วแบบบางทีมันก็ข้อสอบมันก็ไม่ได้นั่นทดสอบคุณได้ทุกมุมนะ มันก็จะลำบากตัวคุณเองแหละนะ ฝึกปานสายฟ้ากันให้เก่งกาจนะ ฝึกให้เหมือนเซนอิสึให้เป็นเลิศในตรงนั้น Hello can you hear me
ค่ะ ได้ยิน
Okay, I will provide you the first solution. Okay, the second and the third, I will don't forget to remind me to give you in the next time. Okay, when the class is the lecture is start. Okay, this t e minus. Okay, the determine the bilateral Laplace transform of the function xt when xt equal to t e to t ut. Okay, this term is the same as the previous. Okay, the key is okay. It have two main steps of this Laplace transform. Okay, the first one, due to the xt function is the term of the ut function. Even though the questions ask you to determine the bilateral Laplace transform, but for the real integration, it seems to be the unilateral. Because the range of the integration reduced from 0 to plus infinity. Okay, after that you get this term. Okay, you can grouping them okay, to be EAT. A in this case equal to minus S plus minus 2. Okay. Use the Bipart integration skill. Okay. Okay. From the Bipart integration, integrate U dV equal to UV minus integrate V du. You integrate them U equal to T, V equal to E minus S minus 2T. And you integrate them and distribute them in this form. Substitute the range of the integration from 0 to plus infinity. 0 to plus infinity. Okay. 0 to plus infinity. Okay. This term, anything power minus infinity, give you 0. Okay. And this term will be 0 too. Okay. Only this term left. You can see that only this term. Okay. And you can see that will be grouped and become to be S minus 2. In this case, how many poles we have? We have 2 poles. Okay, S power 2, right? S minus 2 power 2. You have 2 poles, but both poles will be located at plus 2 location. Okay. The Laplace transform of them will be provided here, and you must get the ROC. Therefore, the Laplace transform of this function is exists only when the ROC will be greater than 2. Okay, greater than 2 because the pole located at 2. Okay, the pole located as 2. Okay, and okay, you can see that the first pole is the red, the second pole is the green. Okay, and the ROC will be the yellow zone. Okay, this is in the example. Okay, for here, you can see that this question is required the bypass skill. Okay, the bypass skill and the other integration skill is required during integration step. Okay, but the key of the Laplace transform, you must know how to model xt and substitute them into the Laplace transform's equation. The rest is based on the basic skill that you already know before. Okay. Yeah. Any question? Okay, I don't provide you so much. Okay, if you have the time, you already have my book. Okay, you already take the exercise in the book, and if you have some question, you can ask me. Hey, Ajahn, do you have this solution? Do you can show this solution or not? Okay, I provide you only a few. Okay, now this is okay for the 1.2 and the 1.3. Do them as the homework. Okay, as assignment, and the next time before the class will be start, I will provide you solution. Okay. Any question?
No, Ajahn.
Okay, therefore, okay, good luck. Okay, dismiss.
thank you ครับ
Thank
อา
you,
จารย์
Ajahn.
You're welcome.
Thank you, John.
ขอบคุณค่ะ
ครับผมโชคดีครับ
thank you อาจารย์
You're welcome.